regulatory track, we're going to be addressing that concern. We're going to be asking that question of what operations are you being asked to approve? Why aren't you able to approve them? What is the gap in knowledge? And how do you overcome that gap so you feel comfortable approving these things? Who here, show of hands, is concerned about security if everybody has a drone? Yeah. Yeah, you don't have to be bashful, I know. Security is a big concern. And there are ways to mitigate that risk. There are ways to increase and innovate commercial operations and still be safe and secure and reliable and resilient. Another issue that civil aviation authorities have to address each and every day is what is the reality versus what is the fiction. We have, in this industry, we have a lot of drone operators who will come and try to sell you an idea and say, we can fly for 13 hours straight in vertical takeoff and landing, in rain, in snow, underground, underwater, hybrid everything, refrigerator, kitchen sink, and it's just not real, right? And you need a mechanism to discern between these two. And so that's another thing that we'll be talking about in the regulatory track is how do you discern what's real, what's fake, and how do you identify what opportunities can exist? From a societal perspective, what does industry and academia need? They need access to airspace. They need to be able to test, to acquire data, to prove that their operation is real. They need standards and best practices or alternative means of compliance to meet your requirements as a civil aviation authority. And they need transparency on decision-making processes. Licensing and training that's identified by the Civil Aviation Authority as acceptable means to prove that they're capable of flight in your airspace. So in terms of policy challenges that we're still looking at that won't be solved today, we're looking at open source software as a mechanism for flight. It's a concern. We have to understand where our software, what it's doing. And how does the Civil Aviation Authority, with little experience and oversight in software certification in your backyard, deem it safe and accessible? Do you just look to FAA and EASA to say that this is an acceptable software, or do you have other mechanisms to meet that goal? Do you wait for ICAO to say, this software is good, this software is bad? Because that's not their role, right? And then finally, we have this whole new world of machine learning and artificial intelligence that we need to bind. We need to find out what the performance mechanisms are, what the requirements are to feel comfortable and safe that it's even meeting the basic minimum of what you need. I don't even want to get into bogus parts and noise and sound concerns and privacy issues tomorrow, but these are things that we will need to talk about because the minute there's 50 drone delivery operations going over someone's backyard is the minute that they're in your office yelling at you because it bothers them, right? So how do you engage the public? How do you ensure that that cost-benefit analysis, that social benefit, is discussed in a productive way is one thing that we'll be talking about. So finally, we work often at a political level. The World Economic Forum is used to operating at a high political level, and this new initiative based out of San Francisco is really gambling on this idea that we need to work at the technical level to ensure that implementation of forward-looking policy takes place in a productive way. We need to look at holistic risk, one that balances the needs of the many rather than the myopic view of just one concern, right? You need to be empowered to make decisions that you deem appropriate. And so that's something that performance-based regulations can help with. And lastly, from our perspective, it should always tie to a human-focused goal. At the World Economic Forum, we look to the Sustainable Development Goals as one of those measures where we like to spend our time in environments that can really do good for society while mitigating the risk to society. I look forward to working with all of you in the regulatory track, or those that are interested still that I haven't bored to tears. And if you want to know more but don't want to quite commit to this yet, I'm happy to talk with you after our conversation today. Thank you very much.
So I must say, I'm pretty sure that Lindsay actually does all the work because he made that sound really exciting. Clearly not a policy guy. So I just want to reiterate, these last 3 sessions that you've been listening to are all teasers for the longer expanded tracks that you'll be in tomorrow. So have a think about it, see what excites you, what interests you, and then you'll be able to go into those sessions either up here or down on the first floor conference room. So from now we move into technology. Our next speaker, Jean-Christophe Souffret, is the co-founder of SenseFly, a leading company in autonomous mapping drones, which he co-founded. SenseFly's solutions simplified the collection and analysis of geospatial data, allowing professionals to survey in agriculture and engineering and for humanitarian aid purposes. It allows people to make better decisions faster. Jean-Christophe, ladies and gentlemen, please welcome him to the stage.
Thank you. It's a pleasure for me to be here today. As SenseFly founder and ex-CEO, I just got retired in May, I would like to give you my perspective on a more business perspective and what I think in the end of the day about whether delivery drones could be the next big step after drones for surveying and acquiring data. But before I do so, I would like to be very clear with you and tell you how much passionate I am about flying devices so that you can understand my bias. So it started already very young, looking at aircrafts, dreaming about becoming a pilot, maybe to do something good with piloting, being a helicopter pilot to save lives and go in urgent situations, help people with fires and stuff like this, not only showing off with girls. So I tried to become a military pilot in Switzerland, and I had the opportunity to fly very nice aircraft, turboprops, but I got fired towards the end of the process, and that was, I think, a good thing for me, because then I could keep going with my engineering studies, and in the end, do some research about bio-inspired flying devices, taking inspiration from flies and insects, in order to turn those learnings into interesting flying devices that could fly, for example, in cluttered environment, avoid obstacles, avoid eating people. And finally, create SenseFly, which some of you may have heard about, and I will say a few words more in a minute about this. I didn't stop flying since then. I kept flying, for example, aerobatic airplanes, exploring the 3D of the sky. I did some competition at the national level. I also learned landing on skis in a difficult situation. For example, this is landing on glaciers where the performance of aircraft is really limited and where you always have issues with wind, with visibility, with sun, glazing on the ice and stuff like this. And more recently, I started to fly helicopter and also learned to fly helicopters in difficult areas, like landing in the middle of trees, confined areas. And so I know about, landing those crafts in situations where you don't have a nice runway, and sometimes it's also very cluttered. But let's go back to mapping drones. So mapping drones, SenseFly basically is the company who became the leader in revolutionizing the way surveyors would work. So basically putting drones in the hands of people that didn't want to fly drones at all. They really just wanted to have a better tool to map more efficiently a certain amount of sites. So SenseFly, that has been founded back 10 years ago, in 2009, as a spin-off of the Swiss Federal Institute of Technology in Lausanne, quickly became the leader in this fixed-wing autonomous mapping drones. Just to give you a few numbers, if that works, we managed to sold thousands of those EB drones worldwide through a network of 200 points of sales. So it's really a worldwide coverage. And we have also not only points of sales, but points of maintenance, because it's very important to be able to service those people, to make sure that they keep operating with their new mapping device. And all of this at an average selling price of around 20,000 USD. So this make a reasonably successful business in the sense that we could prove profitability after a few years of operation. SenseFly, just to give you an idea of the business, the company size, is slightly more than 100 employees nowadays, based in Switzerland. And we spend a lot in research and development to prepare for the future, to always keep improving our products. But we also have a department looking after industrialization, supply chain, production, basically assembling the drones, testing them, etc. And we have to take care about marketing, sales, take care of the distribution network. So that's, I think, is one of the rare companies nowadays that have proven profitability in the drone area business, outside of the consumer world. And I'm also quite proud of being able to say that when The Economist draws the map of the world of drones, well, you will find the Chinese. Of course, we all know the multicopters coming from DJI, for example, or Unique. Or on the other side of the spectrum, you will find the big military drones coming out of the United States. And somewhere in the middle of those two extremes, you will find the EB drones from SenseFly, which position Europe on the map of drones. So what are mapping drones exactly? Well, basically, it's not about carrying heavy loads. It's just about carrying cameras and flying a little bit like a lawnmower in a systematic way over a certain given area. And what really made the difference, back in 10 years ago, there were no possibility to have a drone that would do that by itself. So you would have to learn to pilot those systems. Now, as you have seen today, those systems are fully automatic. So you can put them in the hands of professionals that have no clue about piloting systems, and those systems would just go grab the necessary data. And by taking all of those pictures, you can recognize features on the ground, visual features, from different perspectives. And this allows you to create, after the flight, a 3D map of the site, which is very useful for many people, like surveyors or like mine managers, stock managers. They want to measure volumes. They want to draw the contour lines of the sites, but also people that want to, build new roads, etc. So the drone that we develop is a range of drones, basically, but they look more or less like this. They are smaller than the ones we saw today flying. They are less than 2 kilograms, 1 meter wingspan. Very simple design, 2 wings only, 1 pusher props, and all the necessary electronics brain in order to do the flight by itself. So this is just to show you that a very simple device, of course there is a lot of AI inside it, can revolutionize the way people actually grab data. With such a mapping system, you can go really much faster than going in the field, measuring each of the points with a theodolite or with a GPS or with a laser. But I think what is very important in that case, and it's more the business perspective, is that those systems bring a true return on investment to the customers. And we have seen many of those customers that have seen 5 to 4 times time savings on their projects. So by just leaving aside their good old way of measurement and go for drones, they could really spare money in a very fast way. So just to give you an idea, when a surveyor needs to go out to do a data grabbing session, they would ask between maybe $500 to $2,000. So the cost of a drone represents only a small part, but can be significant in that mandate, and therefore the drone can be very easily, can bring a return on investment very easily. So that's very key. And also in agriculture, now we see situations, cases where drones can really allow growers to reduce the amount of fertilizers they put in the fields while increasing the yield. So basically gaining money and again finding a quick return on investment on the spending on the drone that will provide the intelligence of the crops. So now the question that some of the organizers asked me to try and answer is delivery drone capable of bringing a sound business case or not? So that's a difficult one, and I think it's very early stage right now. But let me give you my perspective. So of course there are very positive signs out there, and we have discussed that already today, and we'll keep discussing that in the coming days. But there is, I think, more and more of a social acceptance. 10 years ago, when we started with SenseFly, drones, we even could not use the word drone because drones were seen as military objects. I think now more and more people are seeing that drones are bringing good impact, and as we discussed, delivering, saving lives, etc. So all of this, and also more and more people have those drones as toys, so they see that they are not really dangerous. So social acceptance is really rising at a fast pace. Also, we hear more and more working groups on rule making for drones, thinking about maybe we should avoid having those drone makers certifying their system as if they were full manned aircraft. And maybe there is a more risk-based approach that could work for drones, because basically drones are flying, less massive, they provoke less risk, and especially if they fly in areas where the density of population is low, like flying over water, for example, then there is no sense of certifying those. And you also have to keep in mind that a drone is not a simple aircraft. If you compare drones to manned aviation, even small ones, drones are more complex because they have autopilots, because they have software, because they have fly-by-wire. All of that is a nightmare if you look at those complex systems from a certification point of view. So applying certification of full manned aviation on drones is an economical nonsense, I believe, and also a nonsense in terms of level of risks. And now regulators throughout the planet start to think like this. So there is also a push in electric powertrains. They become more efficient. They are not yet at the level of gasoline engine, but we're coming there. And we have to acknowledge that there is an improvement year over year of something between 3 and 5%, depending on the reports, of battery energy density. So that's a good sign. And the trick also is that electric motors are far more easier to integrate into systems that are innovative. As you have seen a few drones today, you can put several of those engines, you can rotate those, which was not possible in full manned aviation, or very difficult. Maybe some of you know about the Osprey and stuff. More difficult to achieve in the full manned aviations. Autonomy is price. We see now open source systems that cost almost nothing. I'm sure that most of the people demonstrating their drones today are based on some kind of open source software and even hardware architecture. So the cost of an autopilot, the cost of autonomy is really descending at a fast pace and basically replacing efficiently the cost of a pilot wage. Now, how can we ask ourselves the question whether we can do a good business with drone delivery? Well, that's the tough one. So I took, as an example, as a baseline, as a benchmark, if you wish, I took as I call it, the life bank case. So it seems that operating a fleet of motorcycles to deliver important and urgent medicine products cost, all included, wages, everything, infrastructure, costs approximately cost of ownership of the motorcycles and everything, costs something around 50 cents per kilometer. So I think this is a very good benchmark of the cost of transport a drone should be able to achieve or approach, or a flying device, in order to be competitive with such a way of delivering things. So I did my small exercise, and I put this 50 cents for the motorcycle, and of course a motorcycle is not very expensive, and I asked myself, well, if I took a small helicopter to do the job, maybe it would be a nice activity for me now that I'm not anymore CEO of SenseFly, and flies those products, could I be competitive with motorcycles? Well, the answer is no. It would be 10 times more expensive. And this is based, so it would be good because helicopters are faster. You can carry up to, I don't know, 300 kilograms outside the weight of the pilot. But still, the cost of operation would be quite high. And this is based on numbers that you could find in typical helicopter companies. And interesting to note also is $5 per kilometer also includes everything, so the wages, the insurances, the cost of putting the helicopter in a hangar and everything. And this is based on a number of hours of flights per year of 500, which is not typical for a private-owned helicopter, but quite classical in the case of operation of rescue helicopters, for example. Keep just the number in your mind. So then I asked myself, could I do it not with an helicopter, but with a small short takeoff and landing system, a bush flying aircraft, an aircraft that would take off very rapidly, maybe just 60 meters and you're in the air, and an aircraft that has big wheels so that I can land easily on the countryside. Well, the answer is it's still 3 times more expensive than the motorcycle, even though the acquisition price is low. So we have to do it with a drone. Get rid of the pilot, get rid of some of the overheads, and the number would look more or less like that. So I'm sure we heard today about numbers. I'm sure that we can come up with a drone that would cost approximately the price of a big car. So I took 30,000 USD. And at that price, we can certainly not have something that looks like a small helicopter, manned helicopter, but we can certainly aim at that kind of numbers. We also heard about those numbers today. 70 kilometers per hour is really conservative, a reach of 150 kilometers, and payload capacity between 5 to 10 kilograms, but that should be far more than enough for last mile delivery in many cases. Well, I end up on this number of $50 US, all included, of the price per hour. And this is very tough to achieve, in fact. It's far, far less than the helicopter and the manned aircraft. And this makes me think, with some estimation, we can always discuss the numbers, of course, that this drone would have to fly much more than a manned helicopter in order to be able to be profitable. So if you would be there to build a company that would do that, you would have to fly those drones a lot. And when I mean a lot, I mean more than 10 or 12 hours per day, which means that this brings a lot of challenges together with that. And that would be my concluding slide. So, of course, you need drones that are very reliable, much more than the mapping drones that I discussed before, that would fly maybe once or twice a day, sometimes 10 times a day, but only once per week. So, and every 100 hours, usually you have to do a servicing, a maintenance. And if you fly 5,000 hours per year, you would do maintenance every week. So your system has to be reliable, has to be repairable. You have to be able to make sure that the supply chain is working, that you can have the components in a timely manner. And you also have to make systems that can fly day and night in every weather situation, so wind, rainy, etc., in order to make them really competitive with motorcycles. And of course, all of that wouldn't be possible if you don't have a very strong, so since you need to fly a lot, you can imagine that you will need a lot of drones and in a hub, therefore a high traffic density. And this cannot be possible without unmanned traffic management system, and we'll learn more about this tomorrow, I believe. This is coming. So be able to make sure that those drones are not colliding, be able to dispatch those drones correctly, and communication may also still be an issue. And I'm sure that the Lake Victoria Challenge will help trying to understand at what pace we can tackle those challenges. Thank you for your attention.
So I don't envy our next speaker. He just heard from a risk and security expert who could make policy formulation sound exciting. And the next was a guy who built and flies imagery drones, but also lands helicopters in heavily wooded areas. Our next speaker is Ben Savanen, who's an engineer and a maker, and part of Field Ready's Rapid Emergency Deployment RED team. He's also research engineer at Pennsylvania State University's Humanitarian Engineering program. And he spent the last several years looking at how 3D printing can benefit rural healthcare systems in East Africa. From his work, he co-founded Kijenzi, a social impact venture that uses 3D printing to create both employment opportunities and spare parts in hospitals in Western Kenya. Ben will be enlightening us on drone ports, the costs, benefits, and business models. Ladies and gentlemen, please welcome to the stage Ben Savanen.
Okay, habari za jioni. Okay. So like he said, my name is Ben Savanen, and we're going to talk a little bit about drone ports and infrastructure, starting a little bit today, but going into tomorrow as well. And I should confess, first and foremost, that I'm a little bit of an oddball in that I do not have a drone background. And Field Ready, that we work with, actually does not historically use drones either. But I think a lot of the work we do has actually a lot of potential for us to be able to collaborate, and I think there's a lot of work that we can do together in terms of drone ports. Now, when we look at drone ports, we're not just looking at what's the infrastructure required for being able to have a place where a drone can land and take off, but we're also looking at a potential spot within the community in which the drone is coming and going, and which other activities around it can start to happen, in which different channels of economic flow can start to come into communities in new ways. And that's what I'm going to talk a little bit about today as I talk about the work that we do at Field Ready. So Field Ready is a humanitarian aid organization. And what we do is we use digital manufacturing techniques to be able to short-circuit supply chains in areas where there may not be any other supply chain available, like such as a disaster setting or an exceptionally rural area. If we look at most supply chains the way they exist right now, there's going to be a whole lot of layers from in between the manufacturer and the community who actually ends up using a product. They're going to go through warehouses, there's going to be planes, trains, automobiles in order to get the product to the end user. So with Field Ready, our goal is to cut out as much of that as we can. We want to look to how we can bring the manufacturing of products to the places where the products are needed. Not only does this cut down on time, you don't have to worry about delivery, but you also are able to reduce cost along the way as well, because you aren't paying for all this transportation and warehousing. And so our general strategy is all dependent upon using digital manufacturing techniques. And so as we heard from our friends at Gearbox this morning, this actually encompasses a wide variety of technologies, whether that's 3D printing, laser cutting, plasma cutting, CNC milling. There's a whole range of different digital manufacturing techniques that we employ. And these techniques, though, all generally work on the same basic strategy, in that if you have an identified product need, if there's something that someone needs within the community, all you have to do is create a digital model on the computer, send it via code to the machine, and the machine is able to create a product that's either an end product or a near end product that can go immediately to be used. Now, most of the time, these technologies are being used for prototyping, but in reality, they are getting mature enough to the point where they are able to be used for a whole variety of end-use parts. And because these machines are significantly smaller and more portable than a standard manufacturing piece of equipment, they can go places where other manufacturing equipment can't always go. They can go to places where a factory isn't always there. And so this presents some interesting opportunities as we think about the rural communities around Lake Victoria. If drone ports are places which are all this shipping and commerce is starting to happen, are able to be supported by some of these digital manufacturing techniques, we have not only a transportation method that can go anywhere or almost anywhere with drones, but we have machines that can make almost anything with digital manufacturing. We can imagine a hub in Wanza which is able to create custom products as required upon demand and send them out to the various drone ports available in the Lake Victoria communities. However, an important question before we start getting down alleys like this is to avoid being too hypothetical, is to think about what are the actual product needs that people are seeing? What are the actual difficult product needs that people are seeing? What are some of the items that the people living in the rural areas around Lake Victoria have a difficult time getting right now? And how could a combination of drones and digital manufacturing techniques be able to meet some of those challenges? So in the lead up to this conference, I spent 10 days actually on the islands of Lake Victoria. I spent a few days on Ukerewe, some time on Ukara, and some time on Juma Island to do a series of interviews with people coming from all different walks of life. Doctors, engineers, blacksmiths, et cetera, people who are active and doing work that requires equipment to make their livelihood happen. And I was asking them, what are the things that they really struggle to get? What are the items that they use in their day-to-day life that is a challenge? We've already seen the great things that drone technology can do for delivering medicines or blood samples and testing. But are there other greater uses that it could have, especially when it's augmented with something like digital manufacturing? And from that, I was able to kind of come up with some key focus areas that can kind of allow us to start getting a little bit more concrete in terms of what a business model could be to serve some of these underserved communities with items that they are kind of struggling to get right now. And there's a lot of people out there who are using various small machines to just have their day-to-day livelihood happen. A lot of tailors, a lot of people who run small copier stands, people who use photocopy machines. That is where their day-to-day livelihood is happening right now. And as those machines are all different and they all use different components, it's not uncommon for some of those components to routinely break. When those components break, if you're living on one of the smaller islands, you have no option but to go all the way to Mwanza to look for a new one. And as parts aren't standardized across products, there's a good chance you're going to have to do a significant amount of hunting because the spares market even here in Mwanza is a little sporadic. So a lot of people are losing not just the money that it costs to make a spare for a small machinery, but they're also losing all the time that they could have been working while they're traveling, and they're losing the cost it takes to transport. Not to mention that with local manufacturing, even without these extra costs, is often far cheaper. We can see by 3D printing some gears like that, we can make it for almost a tenth of the price. There's also a number of technologies that people are interested in that could have a big impact on their lives that they don't have access to right now. And the reason isn't necessarily as intuitive as you might think. You can order an irrigation kit, including small parts like this, in Mwanza, but it's not going to come from Mwanza. It'll be delivered from Arusha or Dar or Nairobi. And by the time it gets to you, it'll be at least a month. And while irrigation is actually highly needed in a lot of the rural areas around Mwanza, a lot of people aren't doing it. And when I talked to farmers about this, their answer was generally, sure, I can order the kit, but what happens the first time it breaks? I can't wait another month until a part is delivered the first time my cow steps on a sprinkler. It doesn't make financially sense. I need to be able to have a way to quickly get spare parts and repair this large system that I'm investing in. Along with irrigation in general, pumps are a major issue everywhere I went. As soon as you bring up pumps, people sigh and talk about, oh, pumps, where am I going to get spare parts? For something so vital as delivering water, being able to manufacture locally the parts needed to repair these could have a huge impact. Now, not all of the needs that people were showing me on the islands are necessarily involving urgency or short-term needs, but they are high-impact needs. I met with a number of teachers who told me about how difficult it is to teach science in a rural secondary school when it's difficult to get the parts and equipment that they need. You can't get kids engaged in science, and you can't raise up the next generation of engineers and scientists when they can't participate in the lab. Kids get turned off and they turn away. But school budgets are too tight to make this equipment available to everyone. They also gave me examples of physiotherapy devices. There's all kinds of assistive devices that people with disabilities in rural areas can currently not access because they're too expensive. And even if they could afford them, they're not exactly sure where to go to get them because they're coming from rural areas and these devices are being imported into the major cities. Something like this, a Dobbs clubfoot brace used to treat infants, is $300 to import right now and could make a huge difference in a child's life. With 3D printing, we've demonstrated that this can be made in an open source design for $10 US. It's a major cost reduction in making an item available that wasn't previously available. Some of the biggest, though, and we kind of keep ramping up here and how big of an impact these can be, is medical spare parts. So we look right now at an example of this machine. There's a belt on it that routinely wears out. Because this belt is specialized, and they only make so many of them, to get a new one involves going to Dar and paying the equivalent of $130 US just for a small plastic belt. With something like localized 3D printing with localized manufacturing with 3D printing, we could manufacture something like this on site in a rural hospital where this photo was taken for less than $1. And this is kind of a case, again, over and over again with hospital spare parts. I've spent a lot of time here and elsewhere looking into this. And there's a lot of machines in which there is no supply chain right now for spares. An example of this suction machine used in surgeries, when this part fails, the machine is done, unless someone can happen to find another broken machine and take the part off that one. In this case, something like this, though, this small plastic valve is all that needs to be replaced. And on a 3D printer, we could easily repair that in a matter of hours for less than $1 as well. And this is a recurring thing. Even within the last 10 days, and I was only spending part of my time focused on health, I came across dozens of examples of medical devices that required spare parts, and yet the people who were working in these facilities had no access to spare parts, whether due to logistics or finances. And this is reflected in the fact that it's estimated, the lowest estimate I've seen is that 40% of medical equipment in rural sub-Saharan Africa is currently derelict right now. And a huge contributor to that is spare parts. Probably in the Ukerewe Islands alone, there's at least tens of thousands, if not hundreds of thousands of medical equipment that is sitting there that is unable to be used. Being able to manufacture spare parts locally could have a huge impact in restoring that equipment. Now, I chose some pretty extreme examples out of my findings from these last few weeks to show you. But we can see how by using some of these manufacturing techniques, there's major cost savings that can be had in a lot of products. Not only that, but these products are all having to be attained from somewhere far away. And they're actually all fairly lightweight products too. And so as we go back to this model of a drone port, maybe. We can imagine a hub in which a lot of these goods are able to be restored, where thousands of dollars of idle equipment across all of these sectors is able to be restored quickly, efficiently, and cheaply. We can imagine a workflow in which someone identifies something that they need to have replaced, and they go to their local drone port, either on foot or they send it to the main drone port in Mwanza to be repaired. A local maker is able to take that part that needs to be replaced, create a new one, catalog that design, and then return it to them. And with how massive the savings are on some of these parts that we're seeing, like how big the reduction in cost is, there's room for both the entrepreneur, whether it's a youth from the community that's received some training or not, to be able to make a substantial profit while the customer is also receiving a product that they need for substantially lower than they would have paid otherwise. And so this creates a very exciting opportunity for what drone ports could be. In terms of, again, this whole idea of being able to make anything and be able to deliver it anywhere. But I think models like this, where there's kind of a central manufacturing hub, is really just the start. As I spoke to people, what got people really excited was about the ability not just to get a hold of goods and services that they needed at a lower price or faster or more efficiently, but they got really excited about the idea of being able to manufacture within their own community. And as we continue to talk about tomorrow drone ports and what they could be, there's a lot of potential for them to be their own smaller scale manufacturing hubs that are able to be supported by maybe a larger hub in Mwanza. In this case, community members are becoming not only consumers of products, they're not just taking from Mwanza as is, but they are actually producing for themselves, creating their own profit centers within their communities, and perhaps being able to trade and exchange with the other communities around them as well. This allows them to have much more control over their own economic futures, and it creates a much more democratic manufacturing process where there's much less dependency in the system and people are empowered. So I threw a lot at you. I'm excited to talk more about it tomorrow in the drone port track. I think there's a lot more for us to talk about what drone ports could be. And I'm excited to continue learning more about the thoughts and experiences that people in that group have. Feel free to contact me. Field ready if I don't get a chance to talk to you in the next couple of days, but I hope I get a chance to talk to you in person. All right, thank you very much.
And thus ends the formal speeches or presentations for today. We have been very kindly invited to a reception which will be hosted by His Excellency Arthur Matley, the Ambassador of Switzerland to Zambia and the East African Community, which will be starting at now, 5 p.m., downstairs on the lawn where we had lunch. After that, there'll be a lakeside dinner in the same area, and then we'll be having buses going back to each one of your hotels that will leave at 7, 7:30, and 8:30 from the parking lot. It's been a long day. There's been a lot of interesting ideas that have been shared and a lot of interesting conversations that have been started. I think we need to all take a moment to appreciate that this is another step towards unlocking and harnessing the power of the fourth industrial revolution for Africa. We'll continue to share, continue to learn, and continue to work together to unlock the potential of our African skies. Ladies and gentlemen, thank you very much.